Real-world challenges for AI robotics. Robotics manufacturer 1X, formerly known as Haloti, recently announced that it has raised $23.5 million of new investment capital. A key player in this investment round is OpenAI, the creators of GPT-4. 1X is working on a humanoid robot called Neo, which the company says will explore how artificial intelligence can take form in a human body. 1X stated that it is thrilled to have OpenAI as an investor, since the companies are aligned in their missions to thoughtfully integrate emerging technology into people's daily lives. This investment represents an early attempt by OpenAI to support linking artificial intelligence to a robotic body plan and sensor array. How quickly will we see the combination of robotic manufacturing and advanced artificial intelligence operating in the real world? That is very difficult to say. We have been working on self-driving cars since the 1980s, and we still do not see large-scale deployment of fully autonomous vehicles. The real world is really hard. Of course, with autonomous vehicles, engineers and software developers must develop a system that is nearly flawless due to the tragic safety implications of system failure. Let's look at a much more simple challenge with very low risk to human safety. Suppose we wanted a robot to pick up trash at a local park. The first thing we need is a robot body plan with adequate movement intelligence to navigate our park. The good news is that we can use an off-the-shelf model. A Boston Dynamics Spot should be able to do the trick. It moves around well on its four legs, and as a bonus, we should be able to get a model with a robotic arm with adequate mobility to pick up trash. It seems we are almost there. All we need to do is install AI and tell it to go pick up the trash. Well, not really. The next thing we have to do is to map our standard environment. We need a sensor map of the park so that our robot can understand our search parameters as we hunt for trash. And this map cannot just be any map. Our map of the park has to be intelligible to the specific set of sensors with which our robot is equipped. So we need specific movement intelligence geared to our robot's body plan and specific environment mapping tailored to our sensor set. Once we have this in place, it's off we go. Hey, Spot, go find trash. Well, not quite. In the real world, the environment changes. We might find one of these in our park. Or one of these. Our robot needs to be trained on how to safely respond to the changes in the park environment. And of course, in the real world, unique events can occur. Our robot has to be prepared for the changes that will inevitably come. Sometimes in the real world, it even rains. Well, let's say that after a great deal of work, we feel that our robot is ready to interact in the changing environment of our park. Now we can instruct it to go out and pick up trash. But wait a second. What is trash? Trash comes in thousands of shapes and sizes. Our park is like a giant. I am not a robot, CAPTCHA. Hey, robot, look at this picture and try to figure out what is trash and what isn't. We will have to train our robot's specific sensor set to determine what is trash and what isn't. This training is going to take some time. We might approach this problem in the following manner. We could use drones to photograph our park several times a day. Then we could hire someone with skills in aerial photo reconnaissance to analyze our photos and to calculate the rough amount of trash in the park. We could then observe and track how much of the total trash our robot is able to recognize and deal with each day in comparison with the total trash available in the park. Over time, as we train our robot, it should get better at figuring out what trash is. But recognizing trash isn't our only problem. Once our robot has found trash, it needs to develop an arm movement plan to effectively grab the trash and put it in its basket. If we can create a feedback loop, our robot should be able over time to learn arm movements that end up with the target trash in its basket. Then, of course, we have to develop a system to recognize when our robot's basket is full. Once its basket is full, we have a whole new problem. We have to teach our robot to find trash cans in the park, and to develop a full set of movements to empty its basket into the trash can, after it determines whether the trash can is empty enough to receive the trash from its basket. After we have overcome all of these training hurdles, our robot should be ready for deployment. Wow, that was a lot of work. The good news is that some of our training knowledge can be applied to other parks and other robots, as long as they have the same body plan and sensor set. Or we could just do what we do now. Put up signs and hire some guy to pick up the trash.